Hi everybody, welcome to this video that talks about sample size, which is an important aspect of survey research. We collect observations from samples in our survey so that we would like to find out the value of interest in the population. For example, if we want to find out the household expenditure, the average household expenditure in the population, one way to estimate is to get a subset of the population, which is a sample, and get the observation from the samples, and then we do the averaging of the household expenditure. So we will get a statistics, the average sample household expenditure, to approximate the true value of the population average household expenditure. So in doing so, we may have errors. There are two kinds of errors that may set in. One is systematic error, which is a type of error in statistical analysis that occurs when there is a consistent bias or the deviation from the true value of the variable. For example, if the population average household expenditure is $5,000 US, and the estimation from the sample is $4,500. Therefore, there is a deviation of $500. That is an estimation error. Systematic error can occur due to issues such as faulty measurement tool, bias, data collection method, or flawed study design that do not accurately capture the true nature of the sample from the population. So basically, it's due to the nature of the poor design, and even if the design is all right, but the execution is not correct, then it will induce systematic error. So systematic error can be induced from the respondent and also from the administrator. The other kind of survey errors is random sampling error. It is the difference between the sample result and the result of a census conducted using identical procedures. A random sampling error occurs by chance. No matter how good we do our sampling procedure, there will be estimation error. For example, we have this sample one, the estimation is $4,500. Sample two, the estimation is $5,200. So it will not be close to 5,000, the exact true value that we wish to establish. So although it happens so, but the estimation is still reliable estimate. Now there's a relationship between sampling error and sample size, in which we can see from this graph, the y-axis represents the random sampling error, and the x-axis represents the sample size. We can see that in order to reduce the the random sampling error, we have to increase the sample size. So that's the way to reduce the random sampling error. We cannot eliminate it, but we can reduce it by having a large sample size. Whereas systematic error focus due to design or execution. So that error can be totally reduced to 0 if we have perfect design and also proper execution of the study. Sample size. Sampling design is important to establish the representativeness for the sample in order to have a general conclusion. So we have talked about in our previous video about the probability sampling, non-probability sampling techniques. These are the techniques allowing us to do our sampling. Sample size is also important in a survey because it will ensure certain level of confidence and preciseness. For a quick preview, all right, if our population size is 100, then we need at least 80 observations or 80 subjects or respondents as our sample size. When the n is 1,000, the population size is 1,000, the sample size is 278. For population size of 1 million, we need to have at least 384 samples. So we can refer to Shakaran textbook on this matter. Rule of thumb, sample sizes larger than 30 and less than 500 are appropriate for most research. Where samples are to be taken into subsamples, let's say we want to consider the different impact of these males and females, or the impact of COVID-19, for example, on males and also on females. Then a minimum sample size of 30 in each category is necessary. In multivariate research, whereby we have included more than one factors, the sample size should be several times as large as the number of the variables in the study. For simple experiment with tight experimental control, successful research is possible with samples as small as 10 to 20 in size. Here's the formula for us to estimate the minimum sample size that involves the calculation of averages or means. N is equal to the square of Z times S over E, where Z is the standard value that corresponds to the confidence level. If we want to have 90% sure of our estimation, the Z value is 1.65. If you want to have 99% sure, then the Z value is larger, all right, it's 2.57. S is the sample standard deviation or estimate of the population standard deviation. So we can use sample to estimate the standard deviation, which shows the variation of the value. Right? If the standard deviation is big, that means the values of the variable, let's say the expenditure, could be very big and very small. Okay, so the larger the standard deviation, the larger are the values to the left-hand side or the right-hand side of the average values. E is the acceptable magnitude of error, which is the plus minus part. For example, we want to estimate the mean household income or mean household expenditure plus minus 100. All right, so if the estimated value is 5,000, so the range is this 4,900 to 5,100. If we estimate it for 99% confidence, that means we are 99% sure that in the population, the household expenditure are between 4,900 to 5,100. 100 in this example. Suppose a survey researcher studied expenditures on students' dinner. Wishes to have a 95% confidence level and a range of error of less than 2, so it's plus minus 2. The estimate of the standard deviation, for example, somehow is $29. So by applying the formula, we need a minimum sample of 808 observations. So when we need a minimum of 808, when we distribute the questionnaire, for example, then we will have to distribute much more than 808, so that the return and complete version that is able for us to do analysis is at least X4X. Over here, it is a combination of different Z, S, and E to find the N. Okay. So for example, if we have Z is 1.96, that is to be 95% sure our sample size should be 808. Whereas if we are we want to be even more sure than that, so 99% sure, so the Z is 2.57. In that case, you need to have much higher sample size for you to establish 99% confidence of your estimated result. If you, for some reason, do not have a big finding, then you will think of reducing the sample size. How are we going to reduce the sample size? Number one, be less confidence. So at the expense of, okay, reducing the level of confidence, we can see that if we just want 90% sure, then the Z is 1.65, and you just need 573 sample. So if we want to reduce further, we can consider other aspects like E. Instead of we just want very precise plus minus 2 margin of error or the magnitude of error, all right, we can, let's say, have bigger E. For example, if we have 4 instead of 2, then you just need 144 as the sample size. If you are able to get a lower standard deviation, that means if the residents in that area that you are studying, their income are more or less just near to the average value, very close to the average value, so much so that the standard deviation is 10, is less than 29. Then in that case, because of the homogeneity, we get one case, 2 cases, it is good to represent other cases, so you need 69. If the variance is 29 as compared to 10, we say if there are more variety of expenditure, some are extremely high, some are extremely low. All right, so in that case, to be representative of the population, then you need higher number of sample size. So how to reduce sample size when necessary? It is at the expense of less confidence and larger magnitude of error. Next is to determine the sample size for proportion. Proportion, how many percent of your customers? All right. What is your market share of your customers? For example, this is talking about proportion. So N is Z squared times P times Q divided by P squared. So P is a proportion belonging to specific category. Let's say they are your customer. 40% of the buyers of this toothpaste are using your brand. So P is 0.4 and Q is the complement. Okay, so the counterpart. So Q is 0.6. So Z is still the same value as before, and E this time we use the percentage. So smaller sample is possible, okay, at the expense of less confidence and margin of error, the same situation like just now. Sometimes we don't have the estimate of the P or the Q or the proportion belonging to specific category, we don't have it. Then we just let it to 0.5. If P is 0.5, Q is also 0.5. With this, if you go and calculate it, all right, you will find that when P and Q is 0.5, the sample size, the N, will be the largest as compared to P and Q of different values. So with that, you ensure yourself you can miss important information to enhance the to ensure the preciseness and the level of confidence. A researcher wants to study a market segment of company A's product. He expects population proportion of consumers of company A in that location of study is 60%. So this one refers to the P. The researcher wishes to have an error of less than 3.5. This is E, and to be 95%. So this refers to the Z later on of 1.96. Right, to be made from survey. Calculate the required sample size, the N. So after you plug in the values into the formula, you find that you need at least 753 samples. All right. So with that, thank you everybody for your attention. See you in other videos.